Hello, geometry friends. This is Ms. Backfish, and I want to look at a particular area and perimeter on the coordinate plane question for you. Specifically this one. Go ahead and take a second to read it maybe. And what I want you to notice here is, first of all, it's a right triangle. Okay? We don't always know that. We're not always told that. So let's go ahead and graph it. We've got D is at -4, -1. E is at 1, -3. And F is at 3, 2. Okay, so I've been told it's a right triangle. So I'm looking to see what seems to be the right angle. Let me just connect those. And it seems to me like the right angle is right here. Now, if I didn't have a right triangle and I needed to do area, area, remember, is 1/2 base times height. And the key thing there, that's in a triangle, excuse me, the key thing there is that the base and the height have to be perpendicular. In other words, excuse me, pretend that's the edge. Here's the height. I'm just missing all the dots here. Here's the height, then here's the base. Okay, base and height have to be perpendicular. There has to be a right angle in between those two. So if this was just some random triangle that was not right, let's say it was, I don't know, this guy. This could be really challenging because I have to find a way to go from any one of these points, like maybe this point, to the opposite side in a way that's perpendicular. And I don't even know where this point is, where I'm going to go. So I have to figure that out. You actually know how to do that. You actually know all the things you need to know in order to do that. But it is a little bit of a challenging process. It's kind of a longer process. So my preference is if they either give me a triangle like one we did the other day, where one of the sides is either horizontal or vertical. So I could say, okay, this is going to be my base, and I'll figure out this distance, and that can be the height. Or if it's a right triangle. Now, let's suppose, though, that they did not tell me it was a right triangle, because that could happen. If they didn't tell you it was a right triangle, you would have to figure that out. You would have to find out if it's a right triangle. Easiest way to find out if it's a right triangle has to do with what we've been doing recently. We've been talking about perpendicular lines. Well, if this is a right angle, then these two segments are perpendicular, right? So if I find the slope of this segment and the slope of this segment, I should be able to tell if they're perpendicular. Because remember, perpendicular lines have opposite reciprocal slopes. So I could find the slope of FE using the slope formula and the slope of DE using the slope formula, and then compare. And I've already done that. If you want to pause and try it yourself, you're welcome to. Here are my results. And we already knew this because this one was given to us, but just in case you have to confirm it yourself, this is how you would do it. I found that EF has a slope of 5/2, DE has a slope of -2/5. These numbers are opposite reciprocals, opposite signs, and upside down. That's what opposite reciprocal means, is both things. So yes, those are perpendicular lines, so this is a right angle. All right, so now that we've established that, that's going to make finding the area a lot easier. Because we talk about area of a triangle is 1/2 base times height, right? And the main criteria there between your base and your height, your base has to be one side of the triangle, any side. It doesn't have to be the bottom. It could be this side here or this side here. And the height just has to be perpendicular to that. So if you have a right triangle, anytime you have a right triangle, the two legs, remember the legs are the sides that meet at the right angle. The two legs already meet at a right angle. Okay, so either one of them we could call the base, and the other one then is the height. So another way of thinking of that is, in a right triangle, the area formula for a triangle is just going to be 1/2 one of the legs times the other leg. And that's always true in all right triangles. If you're trying to find the area, the two legs serve as your base and your height. And it doesn't even matter which is which. So now that we know it's a right triangle, I know that I can find the area of this right triangle by doing 1/2 one of the legs times the other one. Doesn't matter which one I put first. So I'm going to put DE times FE. And remember, a segment name with nothing over the top means the length of that segment. So this says 1/2 the length of DE times the length of FE. So I need to find the lengths. The length of DE, the length of FE. All right. How about some distance formula? Distance formula says take the difference between the x's and square that. Difference between the y's and square that. It's really the same thing as Pythagorean theorem. So if you want to use Pythagorean theorem, but I don't mean for this whole triangle, more like if you want to find one side length and you want to use Pythagorean theorem to do that, then you make that one side length the hypotenuse of a right triangle. And that can help you find the difference between the x's and the difference between the y's. And that's how you can find this length. It's the same thing as distance formula. Really, they're just same thing written two different ways. Another thing to be aware here is it really doesn't matter what order you subtract the x's in or what order you subtract the y's in, because you're about to square it. If I did, for instance, let's suppose my numbers were 5 for the x for one point and 3 for the other point. 5 minus 3 is 2. 2 squared is 4. What if I did it the other way? 3 minus 5. Well, that's -2, but -2 squared is also 4. So when you square it, it takes care of the fact that you might have done it one way and someone else does it the other way. All right, so let's go ahead and find lengths DE and EF. I'm going to use distance formula. EF, here are my coordinates. The difference between the x's is 3 minus 1. And that gets squared. The difference between the y's is 2 minus a -3. Remember that when you have minus a negative, that turns into plus. So this is going to turn into 2 plus 3, which is 5. This is 2. 3 minus 1 is 2. So I've got 2 squared plus 5 squared, which is 4 plus 25. It turns out to be square root of 29. Okay, I'm not showing every little step. So if you would like to, you are welcome to do a little bit more, show a few more of the steps in between here. All right, and then we've got DE. Here are my coordinates. The difference between the x's, 1 minus -4. And again, you could do that the other way. You could do -4 minus 1. It does not matter. 1 minus -4 squared plus difference between the y's, -3 minus a -1 squared. This becomes plus, so 1 plus 4 is 5. 5 squared. -3, this becomes plus, -3 plus 1 is -2. So -2 squared. -2 squared is 4. 5 squared is 25. So again, 25 plus 4 is square root of 29. So this happens to be an isosceles triangle. So we now know that this length is square root of 29 and this length is square root of 29. Now, for area, that's all I need. I do not have to find the hypotenuse to find the area of a right triangle. I just need the two legs. 1/2 leg times leg. Let's go ahead and say that. Leg times leg. So my area here is going to be 1/2 square root of 29 times square root of 29. Square root of 29 times square root of 29, any square root times itself is just the number. That's what square root means. This means a number that if I multiply it times itself, I'll get 29. So this is 1/2 of 29 or 14.5. There's no units here, so just leave it like that's fine. It would be square units if we had units. So that is my area. The two things I really wanted you to look at here are the fact that if you don't know it's a right triangle, you can use the slopes to figure that out. I don't even know where I put the sheet where I was showing you that. Here we go. That's what we did. You use the slopes to confirm that you have a right angle where you think you do. And then, because it's a right triangle, you can just do 1/2 one of the legs' lengths times the other leg's length. The length of one leg times the length of the other leg. All right, now, perimeter. Perimeter is easier in that it really doesn't matter what type of shape it is. Perimeter is just all the distance all the way around, which means you add up all the sides. So it's just all the distances, distance formula or Pythagorean theorem, and then add them all up. So if I want the perimeter of this right triangle, all that I need to find still is DF. If I knew what DF is, I could add these all up. Couple of different ways I could find DF. Okay, one is I know it's a right triangle, so if I wanted to, I could use, and I thought I had it in my hand, hang on one second, I could use the Pythagorean theorem. Okay, so right here, I could say, okay, it's a right triangle, and these legs are both square root of 29, so I'm going to do square root of 29 times square root of 29 squared plus square root of 29 squared, and that's going to give me my hypotenuse squared. A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared. That's one way to find the length of DF. The other way I could find the length of DF is I could use the distance formula. If I use the distance formula, I get the same thing. If there are two ways to do something, you should always get the same thing if you do it either way. Here's using the distance formula. If I use the distance formula, this is what happens, and I end up with root 58 again. One thing to notice here is that I'm not simplifying these radicals because I'm going to put them in the problem. I'm going to do something with them. They're not really my answer, so I'm not really worried about them not being simplified. Okay, so if I know, once I know that this side is square root of 58, then all I have to do is add up all the sides. And here we go. DF is root 58, and then I can add these together and get my perimeter. That's all there is to this problem, but I wanted to make sure you saw one like this with a right triangle, just to see what we need to do in order to find the area and perimeter. There is one other thought, and this is kind of like an extension, okay, that you don't really need to know. But since we've already talked about special right triangles, let me point out, because these are the same, this is a right isosceles triangle. Every right isosceles triangle, remember isosceles always have the same angles here. And since it's a right triangle, these two have to add up to 90. So each one of these is 45. So this is a 45, 45, 90. Every right isosceles triangle is a 45, 45, 90. Okay? And the rule for 45, 45, 90s, excuse me, is whatever your leg is, the two legs are the same. And I'm just going to show that these are congruent. That's another way of showing they're both 45. Okay, the two legs are the same, and the hypotenuse is the leg length times square root of 2. So that's another way we could have gotten this. Once we realized, oh, that's a 45, 45, 90, it's a right isosceles, leg times square root of 2. And if you do square root of 29 times square root of 2, you get square root of 58. So that is another possible way you could have gotten the length of DF. I hope this helps, and I will see you later.